Today we're going to take a look at day 6 and our day 6 objectives for today. The calculator's opening up there. We're going to identify whether vectors are parallel, perpendicular, or neither. We're going to find something called the dot product, and we're going to use law of cosines to find angles and length between vectors. So the first thing we're going to look at here is the dot product, and this is if we're multiplying two vectors. And it might be a little easier, so let's say we had vector x, y, and we had vector x2, y2. To find the scalar product, and this is done in a's and b's, it's like saying we're multiplying a1, a2, b1, b2. What we do is we multiply our x value, so x1 times x2 plus y1 times y2, and that's called the dot product. Now if the dot product is 0, the two vectors are perpendicular, and if they're scalar multiples, they're parallel. So scalar multiple being 3, 2, and like 9, 6, because to get from one to the other, we just multiply everything by 3. So the first thing that we're going to take a look at here, these first couple examples, is dealing with the dot product. So P times Q, and again, these should be in parentheses, 2, 3 times 1, 4. So 2 times 1 plus 3 times 4. So 2 plus 12. So we have 14. So we need to find T so that A and B are perpendicular. So negative 1, 5 times 2 and T. So if they're perpendicular, the dot product is 0. So negative 1 times 2 plus 5t has to equal 0. So negative 2 plus 5t equals 0. So 5t equals 2, so t would equal 2/5. Now this next part, we're finding whether they're parallel, perpendicular, or neither. So this easiest is probably to look to parallel. 6 to 2 we divide by 3. Well, we don't divide by 3, so that one's not parallel. 9 to 3 divide by 3. 15 to 5 divide by 3. So this one, it's both divide by 3, so it's parallel. 1 to 0, well, you can't divide. You're not going to end up with anything there. So let's see, 3 to 5. No, that's not the same, so it's not parallel. So let's check out perpendicular. 6 times 2 plus 4 times negative 3. 12 minus 12, well, that's 0. So that means this one is perpendicular. Let's see, 1 times 0 plus 3 times 5, 1 plus 15, or excuse me, 0 plus 15 is 15. So that one would be neither. The next thing we're going to do is see if we can find some lengths here. So if A and B have lengths 5 and square root of 7, and the angle between them is 110, find A times B. So we have one vector, and we don't know what it is. We just know the length. So I could draw it this way. So that's length 5. It's a 110-degree angle. So this is the square root of 7. And that's 110 degrees. So A and B. Well, if this was vector A in component form, it would be 5, 0 times B. Well, we don't know this B in component form, but if we were to draw this in, x and y, there's our x and y components. Well, this is 70 degrees. So let's see, we could use right triangle trig to find this. Opposite over adjacent. The sine of 70 equals y over the square root of 7, and we could find the y component in the x. The cosine of 70, x over root 7. So we could multiply each of these by root 7. And let's see what we find. So, let's see. So trig sine of 70 times square root of 7. 2.4849, so y equals 2.49, and we can go back here and find the cosine of 70 times square root of 7. 0.90. But it's going backwards, so negative. So this has got to be negative 0.90, 2.49. So now the dot product, 5 times negative 0.90 plus 0 times 2.49. So that's just 0. So let's see, 5 times negative let's see, 5 times negative 0.9, 4.5. So it would be negative 4.9. Or 4.5, sorry. So let's see. So let's flip the page and let's see what else we're going to look at today. So on this back side, we have to find the angle between these. And these are supposed to be vectors as well, so parentheses. So we have find the angle between those. So this vector, let's see, we know it goes over 3 and down 2. And this vector over 1 and up 7. And we need to find this angle. Well, let's see, we could put another vector here between them. So let's see, what would be this one? Well, 1 and 7. So 7 squared plus 1 squared. So we got the square root of 50 there. This one was 3 and negative 2. So 3 squared plus negative 2 squared, 9 and 4, square root of 13. And what about this other vector? Well, over 1 and over 3. So what's the difference between these? That other vector has got to be 2 and 9. So 2 squared plus 9 squared. So we have the square root of 85. And now we could use law of cosines to find that angle. So we want to find this angle. So the square root of 85 squared, 50 squared, 13 squared, 2 square root of 50, square root of 13, cosine of, I don't know, I'll just call it A. So we got 85, 50 plus 13, 2 square root of 50, square root of 13, cosine of A. We can combine those, so 85 equals 63. 2 square root of 50, square root of 13, cosine of A, minus 63. So 22 equals negative 2 square root of 50, square root of 13, cosine of A. So 22 divided by negative 2, square root of 15, square root of 13, the cosine of A. And now we can go to our calculator and we can use that inverse to find the angle. So fraction 22 over negative 2 square root of, I already forgot what it was, square root of 50 and 13. And we end up with 115.56 degrees. Now the very last one that we're going to take a look at. Find the measurement of the angle for ABC. So let's see. A, B, C. So we want to find this angle. Well, let's see. Once again, we could find these as a vector. So A to B, 1 and 5. So that's vector 1, 5. B to C, negative 4, negative 1. And let's see, A to C, 2 to negative 1, negative 3, negative 1 to 3 is 4. And now we could find the distance of all these. So 5 squared plus 1 squared, so this side's the square root of 26. Negative 3 squared plus 4 squared, well, that's going to be 5. Negative 4 squared plus negative 1 squared, square root of 17. So if we want to find this angle, we're going to start with that other side. So we got 5 squared equals square root of 17 squared plus square root of 26 squared, 2 square root of 17 square root of 26 cosine of b. 25, 17 plus 26. So let's see, 17 plus 26, 43. Minus 43. So we have negative 18. Divide by all this. And once again, we have to do that inverse cosine. So cosine fraction, and I am terrible at remembering what this was. So negative 18, negative 2 times square root of 26 times square root of 17, so 64.7 degrees.